This video is about sorting out some basic terminology around programming languages. There's dynamic and static typing and compiled versus interpreted. To start off, a few definitions to understand the following concepts. So, a type describes the possible value and the semantics of data structures. For example, you might specify an integer and that comes with some predetermined data structure and operations you can apply to it. Type checking. Type checking is the process of verifying and then enforcing the constraints of types to avoid type errors. This means that the operations should only be applied to data structures that support it. Okay, in programming languages we have different types and we check for those types to avoid type errors. So what is then the big picture process of running code in a certain language? First, we have to translate and evaluate the human readable code we wrote. Then we're doing this type checking. And finally, we obviously run the code. So these different classifications are based on when the translation and the type checking tasks are done. Compiled and interpreted classifies when the translation happens. In case the language is compiled, the translation happens before running the code as a separate step, the compilation. So this is the process timeline. First you write the code, you translate/compile it, and then you actually finally run it in the end. Contrary to a compiled language, a interpreted language translates the human readable code we type into the machine while reading and running the code on the fly, so during runtime. On the process timeline, this simply means that we merge the translate and the running step together as one. So we read and translate and run line by line, step by step. So then, dynamic and static type checking. These two classify the language according to when the type checking is done. Static type checking means it happens before running the code. And dynamic checking, just by the semantics you can already imply, it means it happens while reading and running the code on the fly. Let's look at an example in Python and Java. So here I am in IntelliJ and I'm trying to do something forbidden in Java. Now Java is statically typed and compiled. Well, I gotta be careful here because Java is not compiled like, for example, C is compiled. It's basically a hybrid. It first compiles down to bytecode and that bytecode is then translated or interpreted on the fly into machine code. So it's basically doing both. But here, for the sake of this example, we can just look at Java as it would be compiled. Here, I'm trying to highlight the static typing. I'm trying to assign the string A and I want to do 1 plus A. So before I'm even running the code, it's already highlighting this because it's already checking for the types. And it's saying here, okay, incompatible types. Now let's compare this example with the exact same situation in Python, which is dynamically typed and interpreted. So again, I have here A, which I want to assign to 1 plus A, and then I want to print A. And here it's saying, hey, so far so good. Then let's see what's happening when we run it. And of course, we get then the type error, that we can't merge these two types with the plus operator. We have an int and a string. Here's another example that highlights the properties of Python. I have here an if statement and that evaluates always to true. And then here in the else block, I have the exact same faulty thing from before. Now because Python is dynamically typed and interpreted, we always enter this if statement, evaluate it to true, print this, and then the program terminates. We will actually never enter this else block. And thus, type checking is never done here on the fly, and this code is also never translated into machine code. So we won't get any error here. We can run this code just fine. Well, that's right, of course 10 is smaller than 20. But what would happen if Python was statically typed? Well, in that case, Python would look over the whole file here and check for the types. It would enter here this else block, see that we have here an invalid statement, and it would throw the type error. We couldn't run this code. Would that actually change if Python was compiled and dynamically typed? Well, let's see. So first we would compile this whole file, so we'd check this if statement, which is all straightforward and correct. Then we would enter the else block also this time. We would look at this, translate it, and then it would seem all fine because we actually haven't run the code and thus type checking has not been done yet. So we would be able to run the code, and then when running it, we would always end up just printing this statement, never entering the else block, and thus we would never do actually the type checking and we won't get an error. Now, how do these characteristics of programming languages compare? Let's start with the compiled languages. They have the big advantage in performance. Now, this makes intuitive sense, right? If you compile and translate a computer program once, and then in the future the computer always knows what to do with that program, it's going to be much more efficient compared to having to translate each line of code every time you're executing it, right? It's like you're getting a recipe in Chinese, you translate it once, and then in the future you always know what to do, compared to like translating it line by line every time you're cooking that recipe, right? Compiled languages also offer better control over memory management and CPU usage. They favor catching as many errors as possible early on, but they add an extra step in the developing process because you need to recompile the program every time you make a change. So this might cost you a significant amount of extra time in the developing process. Then, interpreted languages have the big advantage that they're platform independent. They're often easier to use. They're easier to code, test, and change. So they favor quick development cycles. Really, the big picture trade-off is a bit like you trade machine resources against developer resources. A program that is run on a compiled language might have better performance, so run faster, but you might have spent much more time developing it. And an interpreted language might run slower, but you have developed the program faster. But you know, people argue about this all the time. Static and dynamic typing compare in similar fashion. So, static typing offers improved performance due to compiler optimizations. It's easier to work with relational databases because you also need to incorporate all the different data types there. And static typing detects type errors early on. Then dynamic typing is potentially less verbose, so you don't have to specify int, string, and all these special words so that the program knows what kind of type you're specifying there. It offers faster development cycle, but requires often more testing in the end to really, weed out those possible type errors. And it's more flexible to change things up. Finally, what's the connection between compiled, interpreted, and dynamic and static typing? Is a statically typed language always also compiled? No, not necessarily, but it often is. This combination just makes sense to catch all those errors early on. But for example, as a language user, you might also want the performance of a compiled language and the freedom and flexibility of a dynamically typed language. So you would maybe use something like Lisp that offers these qualities.